All right, so we need to understand something called the quadratic formula. But primarily, this discussion that we're going to have is about something called the discriminant. Now, the quadratic formula in all its ugliness is written right here. But we need to focus on the part under the radical. Now, you know that I like to do my quadratic formula in two parts. First part is finding the discriminant. Well, that's b squared minus 4ac. We have got to figure out what this is. Now, why do we have to figure out what this is? There are three scenarios that we need to understand. Okay, if this discriminant is negative, which we have talked about recently, you have learned when a number under a radical is a negative number. Sorry, I shouldn't have drawn that arrow. Then that tells me that we're going to have imaginary numbers. And maybe I should ask this question. Where do imaginary numbers show up on the x-axis? And the answer to that question is nowhere. Nowhere do they show up on the x-axis, which means the pictures that are drawn, if you can look at the two pictures that are drawn over here, you can see that they never cross the x-axis at all. So if you're doing this process, b squared minus 4 times the a value times this, oops, that's a bad looking parenthesis, times the c value, you reach over to your handy dandy calculator and you type that in. You get negative 36. That's going to tell me we're in this scenario right here. And specifically, we've got to be this one over here because we know that the a value is positive, so we do know this thing opens up. But both of these are examples that they have drawn, are both examples of the scenario we're describing. So we have 0 or no, why isn't it drawing? No real solutions. Now, what does that mean? That is also the same thing as saying 2 complex solutions. Remember, complex means that it has the imaginary numbers in it, right? So that's a plus and minus bi, because what we're going to learn is that they come in pairs, and the quadratic formula shows me that they come in pairs because of that whole plus minus thing going on. But in the grand scheme of will it cross the x-axis? No, not going to cross. Well, what if I end up with 0? What if I end up with 0? So I've done my little b squared. B squared minus 4ac. Oops, that's a negative. Don't forget that. Muy importante. Wait a second. What did I do wrong? Okay, I think I see a problem. That's supposed to be a plus sign. Yep. So that would be a plus sign. All right, so we end up with 0. Well, as you can see, it touches the x-axis in one spot. In fact, if you would factor this thing, you would come up with x minus 4 quantity squared. So that means you only have one factor, one place where it touches the x-axis. Not two places, just one place. So it's not doing one of these numbers where it's coming down and then coming back up. It literally just touches the axis and leaves. Now, if you are familiar with Katy Perry, she sang a song about this one. I Kissed the X-Axis and I liked it. And that song is all about the parabola or any polynomial in general bouncing off the x-axis. Now, you can also, we haven't had that discussion yet, so I can't mention multiplicities. All right, forget that. All right, so we have one real solution. That's one real x-intercept, one place where it crosses the x-axis. Well, the last situation is the one you would expect. For instance, when you do b squared minus 4 times the a value times the c value, and you get 49, then you've got two real solutions, two places where it crosses the x-axis. And if you were to do this question, factor this question, you could easily see that the two places are -6 and +1. Remember, you set the factors equal to 0 and solve. But we do have two places where this one, what is that going? Get that thing off my screen. Okay. So literally, b squared minus 4 times the a value times the c value. What do we got there? 24 plus 12? Isn't that 30? No, 36 plus 12. That's 48. Okay. That's a positive number. That's two real solutions. So this is not super complicated, folks. You literally are just figuring out, oh, that's 0. That's one real solution. B squared minus 4 times the a value times the c value. Let's see here. 20 minus 13. -79. That is 0 real. But you also need to be able to tell me that's too complex, because those things go together. So that's important. Rachel tosses a tennis ball straight up into the air, and as she is about to serve, the height of the ball in meters at time t is given by this formula. Will the ball reach a height of 4 meters? Now, whoa, let's lock that in. The 4 meters would go over there. 4 equals -5t squared plus 5t plus 2. You know what I forgot to mention way back in all of this, which is true for the quadratic formula and for if you're solving by completing the square? It must equal 0 to start. Okay? So before you begin this process, that 4 better be coming over here, because we better have it like this. -5t squared plus 5t. 2 minus 4 is -2. Now we can begin the process of answering this question. B squared minus 4 times the a value times the c value. Now these parentheses are kind of useful, folks. I see kids that skip them. And guess what? The squared part, now it's not going to be wrong this time because it's a +5, but when it's a negative number, kids screw that up all the time. So I would suggest that you use parentheses when you're doing this, just to make sure you're not going to mess it up. But I ended up with -15. So will it reach 4 meters in the air? No. Right? And that's, see, because since it's a negative number, that's telling me we've got no real solutions. So never going to reach, never going to get there. So then they wanted me to change it to 3 meters and see if that will happen. Now, I want you to look at something about these questions. They are not asking me to find the time at which it reaches that particular height, because that would be the entire quadratic formula. I mean, if it's even possible. The first one's not even possible. So they're just asking me, will the ball reach? So this is a yes or no. Now, for those of you that think you can just randomly guess without showing me work, show thy work. Don't be lazy. Nobody needs that. Negative 5t squared. Oops, let me make sure I got the right formula here. Plus 5t and a plus 2. And then, of course, we're going to bring that over to the other side. 0 equals negative 5t squared plus 5t and a minus 1. B squared minus 4 times the a value times the c value. Okay, so that ends up being positive 5. So that's a positive number, not a piece of something, but a positive number. So that means yes. It'll actually happen twice, once on the way up. Well, she's hoping it doesn't happen on the way down, because she's hoping she actually served the ball. If it's twice, she didn't do a good job of serving the ball. You know what I'm saying. Okay, next slide. What values of B will cause that thing to have one real solution? Ooh, good question. In other words, we want the discriminant to equal what? We want it to equal 0. That's what we want, the discriminant to equal 0. Okay, so let's back up. We don't know what B is. B squared minus 4 times the a value times the c value. But we do know what we want it to equal. We want that to be 0. So I need to literally go through and solve this. Not going to be that difficult, right? What is negative 4 times 2? Negative 4 times 2 times 18. That's negative 144. So if we want that to move to the other side, we have to add 144. Ooh, this is going to be nice, right? And then, so there are 2 possible answers here, right? And I'm expecting you, to say both of them. There are 2. See, it says values, but it's not, sometimes it can be one answer, right? But in this case, it's 2 answers. All right, for what value of B will we get? We'll have 2 imaginary solutions. Remember, you could use the word complex there because you know that it's got the real plus the plus or minus the imaginary stuff. So, anyway, B squared minus 4 times the a value times the c value. Okay, now, what kind of numbers would create that? We need a negative number. So that means all the values that would make it negative, right? All right, so let's see here. Minus 4 times 5 times 5, we got negative 100. So b squared minus 100 is less than, 0. Getting ahead of myself. The 100 moves to the other side. B squared is less than positive 100. Now, Before we go further, I want to think about this in terms of graphing. So imagine a parabola. All right, we know what parabolas look like. And imagine the line y equals 100 going across. Wow, that is a bad looking 100. Let me try that again. What sections of the graph, maybe I should type that out. What sections of this graph are below, because it says less than, right? Y equals 100. What sections of the graph are below? The reason I want you to see the picture is sometimes the sections would be above, and then you would have two answers. Now, obviously, it's just this section right here. And obviously I didn't draw it very well, but it's that chunk in the middle. Well, that means there's a boundary over here and a boundary over here. Now, I know, you're going to take the square root, right? You know that there's 10 involved, right? Plus and minus 10. But how? How is it involved? Well, you got negative 10 and positive 10. And if you want the chunk in the middle, like we just talked about, that means the answer to this question goes from negative 10 to positive 10. Now, how come? Why not brackets? Why parentheses? Because at those spots, it's equal to 100. I can't have it equal to 100 because then my discriminant was equal to 0, and that's not negative. We wanted the discriminant to be negative. Therefore, we cannot be 10 or negative 10. It has to be in between those. Okay? So that's why we have to have the parentheses, cannot have the brackets on this. Now, what if this question said 2 real? 2 real. So I would have gone through this process, b squared minus 4ac. I'm just going to cut to the 100 part, and it has to be greater than 0, right? I'm not saying that I'm changing the question. I hope you understand, folks. That's why I drew the line in there. So in this situation, b squared would be greater than 100. And yes, you've got your little parabola thing going on here. I didn't do a very good job of drawing it the second time. You got your little parabola thing going on. And then, of course, your line at y equals 100 is coming through here. But this time, you want this chunk and this chunk, right? Two different pieces. Negative infinities over here, positive infinities over there. So it's those two pieces. So when you do your little square root and you find your negative 10 and your positive 10 in this particular scenario, you would have an answer that looked like this. From negative infinity to negative 10, don't forget it's a parenthesis, union 10 to infinity. So in that scenario, you've got two pieces to your answer, not just one. So really good to think through these questions. All right, that's the end, I'm pretty sure, of that lesson, but let me check. Yep, sure is. Have a good day.